Okay, so the next approach that we used for topic modeling was to use GLOVE, which is a popular unsupervised learning algorithm for finding word vector representations that incorporates both local context information like word2vec as well as global corpus word-to-word co-occurrence statistics. So we trained a model on a huge corpus extracting 400,000 word vectors and in 50 dimensions, and from those we extracted the vectors for dimension bank. We clustered those using k-means clustering, and we varied the number of clusters. And on the right, you see the 10 clusters that were learned, representing different topics with the top most frequent words for each topic. Then we generated features from these. So we took all of the contentful parts of speech, and we clustered them to the closest cluster centroid based on Euclidean distance to the cluster centroids. And then for each of the 10 topics, we took the average scale distortion of the vectors assigned to that cluster, so that gives us 10 distance features. And then we also extracted idea density, which is the total number of topics that were mentioned over the total number of tokens in the transcript, as well as idea efficiency, which is the total number of topics mentioned over the total duration of the transcript in seconds. And again, we see that there are a lot of features that are highly correlated with class. We see a lot of the topics are similar to the ones learned by LDA, so controls talk more about details in the picture, like the window, floor, and curtains, as well as the three-legged stool, whereas people with cognitive impairments talk more about the obvious topics, like the mother drying the dishes. We also see that idea density and idea efficiency are highly significant, with controls requiring fewer words in fewer seconds to produce the same number of topics. Then we also took each utterance, and we produced the topic for each utterance by taking the majority vote for all the word topics in the utterance, and we constructed a directional graph where each node in the graph is an utterance topic. Then we computed some graph features like the number of nodes and edges, some connectivity features like the largest connected component and largest strongly connected component and average total degree, as well as some recurrence features like the parallel edges and the number of loops with 1, 2, or 3 nodes. We find that the number of nodes and edges are highly significant, with controls having more unique utterance level topics, which is expected. Finally, we wanted to compare the different topic modeling approaches. So we took all of the features computed by all the approaches, and here I'm showing you the top 10. So you see that there are features that are significant extracted by each of the different topic modeling approaches by the finite state transducer, the LDA approach that Alyssa described, and the GLOVE approach that I just presented. We also directly compared them in classification experiments. So here you can see that the LDA topics and the GLOVE topics perform quite well, achieving 75% accuracy on binary classification. And I'm going to pass it back to Alyssa to talk about mental state.